Okay, so the last 5,000 years, 34 seconds to midnight is pretty much all of written history. It'd be, the last 5,000 years would be 34 seconds to midnight. 2 seconds to midnight in this time scale, industrial era of what we call human progress, exploited and scattered materials from Earth's crust, driven countless species to extinction, poisoned the biosphere, altered climatic balance, altered and exploited ecosystems, really to serve human ends. So you think of that thin biosphere we had, we took all this stuff out of the ground, because when we're talking about oil and burning fossil fuels and that sort of thing, it's a geologic time scale you got to be thinking about, because that's how long it took that stuff to get in the ground, right? So you take that stuff and you hurl it up in the air in this scale, the last 2 seconds. To me, it's a plausible argument that that's going to upset the balance a little bit, right? I heard George W. Bush actually once say, talking about the climate issue, saying, "Don't worry about Earth. Earth will be fine. Earth has got a way of figuring these things out. It makes corrections, right?" Yeah, I agree with that. But if you were Earth, what would you correct, right? So this save the planet, save the world stuff, the planet's going to be fine. It's us we're trying to save. It'll probably shake us off. And the dinosaurs lasted 13 days. We're still trying to last 1. We haven't got to 1 yet. We're 5 hours in. So to me, you can drill down into the numbers on climate change and all that, but it's really about, you look at that and intuitively that just makes sense to me, is that you can't pull all the stuff out of the ground, burn it, and expect there to be no effect, right? So let you think about that for a second. So that's the spatial and the temporal kind of context. Last thing here then is, and I don't want to get too much into the quibbling over different numbers and things, but I just want to put this up because we talk about climate mitigation or carbon mitigation. I want to put that in some kind of context, because I don't know about you, but I try to do good things at home and try to live my life responsibly. And I think, well, if I put in these, what are the light bulbs called? CFLs. It's Canadian Football League. That's why I couldn't think of it. If you put those in, the complex fluorescence, does that do anything? If I take the bus, if I buy a hybrid, what is actually the scope of the issue we're talking about here? So that's what I think this stuff is good for. So let's look at it this way. Here's another metaphor, right? So you can look at the atmosphere as a bathtub, and right now there are about 800 billion. This by the way is from the Carbon Mitigation Initiative at Princeton University. A guy named Robert Sokolow and Stephen Pacala put this together, and it's in Scientific American about 2006 if you want to look it up, or go to their website. And they've got all the facts and figures behind where these calculations come from on there. But this is just to kind of make it sort of, as a friend of mine says, kind of a horsey-ducky story for us, so we can just say, what are we talking about here? Let's give me some scope. So you've got 800 billion tons of carbon in the atmosphere right now. Every year we burn enough fossil fuels, we put 8 billion tons in. Out of that, though, you have what are called sinks at the bottom. So you've got the ocean sinks and land biosphere sinks. So that's plants and trees and things sucking it up, sucking up the CO2, and oceans. Now, forget about the fact for a second, the sinks are becoming less effective because the oceans are becoming more acidic, it's killing coral reefs, and when the ocean gets warmer, like flat beer, it goes flat, it doesn't absorb CO2 as well, right? So there's a problem with the sinks. Deforestation on the land side, if we're cutting down forests and trees and things, there's a problem on that side as well, but let's pretend that stays constant. So that means net, we add 4 billion tons of carbon to the atmosphere every year. So what? Is that a problem or not? Well, most, the scientific wild guesses say that when we get to double CO2 from pre-industrial times, that's when we're going to get into very bad things. And Gwynne Dyer does some great stuff on potential hazards, and I'm not going to get into all the catastrophic things that are going to go wrong around climate change. I'm trying to get a sense of what actually do we have to do in terms of mitigation here, and then start thinking about adaptation at the same time. So today we're at 800 tons, as I said on the previous slide. Glacial times, about 20,000 years ago, it was 400. Pre-industrial, so 200-300 years ago, it was at 600. And they have ice cores to measure this stuff, and it kind of fluctuated in between 400 and 600 for a lot of years. In the last couple hundred years, it's gone up to 800. If we're adding, you can do the math, if we're adding 4 billion in every year, if we add 4 billion in for the next 50 years, where will we be in 50 years? That's 200, we'll be at 1,000, right? So we have to be careful about adding more to get up to that 1,200. Now on this, though, however, this is what our trajectory looks like. Historically, that says 1950 up to today, it's taken us to 8 billion. If this is our historical line, there's an old Chinese proverb that says, if we do not change our direction, we're likely to end up where we are headed, right? And so that means if you keep going up that thing, and that's due to just our natural growth. Population growth really is what sits behind all this. And if you look at the peak oil curve and the population curve, they pretty much map onto each other. And so the fact that we're going to go from 6 billion to 9 billion on the planet is really sits behind all of this stuff, and industrialization of developing countries and everything else. So never mind, if we stayed at 8 and we're adding 4 in, that would take us to 1,050 years. Problem is, we're actually going up from 8. And so what these guys are saying is, our interim goal, as they're calling that piece on the end there, should be to try to at least stay at 4, right? I mean 4 net, so 8 emission right now. So this green part in here, they're calling the stabilization triangle, says we just can't let it grow. Never mind reducing it, we just can't let it grow at that kind of a rate, right? And so what they did, and actually I should say what these guys are trying to do is to say, what can we do actually with the technologies that we have right now? Okay, so what they did is just chop that thing up and say, each of these we're going to call a wedge. There's 8 wedges, and let's think about what these wedges could be. So if we're talking about carbon mitigation in Waterloo region, where would that fit? There's some math around this, and I want to speed through this because I really just want to get to the list. But what a wedge is, 25 gigatons of carbon takes 50 years, and this thing has to be something you can bring to scale in over 50 years to save 25 gigatons. Okay, so here's a list that these guys have come up with. I just want to take a quick survey here because normally in a class discussion, we'd have discussion here in a classroom setting, but I just want to, how about this? I'll just read a couple of these, and when I read one that you think sounds pretty easy, say, ha, like cakewalk, can of corn, we can nail that easy. Let's just try that on 3. Ready? 1, 2, 3. Okay? If it sounds like it's going to be difficult, say, holy cow. Okay? So 1, 2, 3. Okay. If it sounds like it's going to be really difficult, say, holy shit. But there are some here that are maybe harder than others, easier than others. Okay, double the fuel efficiency of 2 billion cars from 30 miles per gallon to 60 miles per gallon. Easy. We can do that. Right, I just saw an ad in the paper today in the Globe and Mail for the new, was it Ford Fusion? Is 61 they're touting it at. Drive 2 billion cars, only 5,000 miles per year rather than 10. Oh, you got, because people don't want to give up their cars? Okay. Okay, I'll skip down a couple here. Let me do number 3, because this is what we're here to talk about too. Cut electricity use in homes, offices, and stores by 25% and emissions by 25%. That's every house, every business, okay? And that's one wedge. Now, what they say here is you need to pick 8 of these. You don't need to do all 15. And number 16 actually is, the sky's the limit. Blue sky. Dream up what you want. Just one or two more. Install carbon capture and sequestration, meaning take carbon, stick it in the ground. For others, that's controversial because some say that's a problem deferred. It's not really a problem solved, and there's issues that's untested. At 800 coal plants. And right now, just to give you some context, right now we're at 0. Although there are a few test sites and some experimental things going on. Although the clean coal lobby will tell you that you watch their ads and you think it's happening, but it's really not. Install CCS new coal plants that produce hydrogen for 1.5 billion vehicles. So there's what they do here. You pick these, and they actually have a board game around this. You pick them, but you can't double count things. And so the point of this one here is there's a lot of things that we can do with current technology that are all pretty difficult. Probably number 3 is, you guys said, that's one that we should just be nailing. It should just be a no-brainer. If we can't get that one, never mind all these other ones. There's some on wind power, ethanol, different things. The other one I think is the most important one is number 16. And one of the things we do in our strategy classes in sustainability is to say, think integratively, think outside what's going on right now, think strategically about what are these issues, and dream up new ideas, and partner with technology and try to solve problems. The other thing that's missing from this list really is anything to do with reducing demand, curtailing population, those kinds of things. So this is being critiqued for that, to being too tech heavy.